I'll be talking about CQI-27 in quite details. This is a special process and is going to apply to all our foundries in India very fast. It has just arrived in India, yet to be implemented in many foundries, but the day will not be far when this will be applicable to even your own foundry. So before it attacks us or it affects us, let us understand what it is. So what is continuous quality improvement? Basically, it is a management philosophy which is used for betterment of your process. Problems arise as a work of poor work design, unclear instructions, or the failure of the leadership, and not the people who are actually performing the process. This CQR stresses the need for the teamwork among all levels of employees. So let us understand what is continuous quality improvement. We are always doing some improvement all the time, but this has got a special meaning when we say it is CQI. So basically, the organization keeps running because of the employees who are doing day-to-day work, and they are better equipped to suggest changes than the leaders or dealing more bureaucratic jobs. They are busy with their own further visionary jobs. So in CQI, employees are encouraged to analyze the work processes. They are encouraged or they should make suggestions to improve the process for good of the company. That is a basic concept. This is a group called Automotive Industry Action Group. It is a unit non-for-profit organization. Here OEMs, suppliers, service providers, government agencies, individuals and academia all came together. They're working together for the last 37 years or so. And this effort is to drive down cost and make it simple for the automotive supply chain. This is a very complex chain. So we are trying to make it as simple as possible by giving us updated information. The organization was founded by three largest North American automotive manufacturers, Chrysler, Ford, and General Motors. AIG has got many important members. The leading global leaders, manufacturers, parts suppliers, service providers, such as Toyota, Honda, Nissan, Volkswagen, Caterpillar, many of their parts suppliers and service providers. Not necessarily the manufacturer, but even the companies who are supplying them something, they are also part of it. So why and how? This is our question. So achieve excellent product quality, manufacturing processes of products supplied to customers had to be robust and stable at any time. For critical processes and the steps like heat treating, plating, coating, welding, soldering, molding, we need additional care. The suppliers and sub-suppliers are required to perform certain annual self-assessments. These are specified in the various booklets. I am giving some names here. CQI-9, most of us are aware for heat treatment. CQI-11 for plating, CQI-12, 15, 17, 23, and 27. So these booklets help us to understand individual processes one by one. But the basic CQI-27 is something different. The CQI principles are what? The person doing the work is supposed to be the expert if it is properly trained. Secondly, us versus them is outdated or counterproductive. The gap between the leaders and down to the bottom of the workforce has to be minimum. Thirdly, leadership need to partner with all employees to empower them to make decisions that can improve quality standards. And fourth is managers must support their each unit strategically and with development. These are some of the principles. Next points are teamwork. Everyone must work for the goals of the unit. Deriving value is an overarching tool. Overarching means like an arc, comprehensive or all-embracing, covering all aspects. Working together beats competition. We know the famous story of breaking a single stick is very difficult, but if you bring 5, 6 sticks together, it becomes very difficult. When the single stick is there, it is very simple. So working together can make you better results. Learning about work is never-ending process. It is ample clear to grasp this basic principle, and simple statistical problem solving or team tools are effective and must be used. And we should focus our energy on fixing processes and then not systems. Many times entrepreneurs are inclined to look at the people for finding the problems. We should encourage them to work and spend our energy on fixing processes and systems and not on the people. Basically, people want to do good work. All people want to do good work. That we must remember. CQI as a contest. The macro version refers to the executive level of the company, that is top management, and the micro level refers to the managers, staff, and workers. There are two versions. So, but both of them have to be working together with a least gap in between. So the title is CQI-27 Special Process Costing System Assessment. So this provides requirement for foundry suppliers of OEM automotive castings. And as I mentioned earlier, it is a collective effort by OEM and tier 2 customers to create common practice, requirements for foundries, and this is going to benefit the foundry industry for their OEM automotive customers. Please remember, this is not a standard to be followed strictly, but the customers are going to ask for it. I'll come to that very shortly. This standard CQI-27 is not a detailed description of the entire foundry process. It is dedicated to certain facets of the process. The focus is on the common failure modes and which OEM customers receive non-conforming casting from foundry. So it is focused on certain aspects in the making a casting. It is written from an OEM and tier 1 perspectives. It is written from the customer's angle, and it is a voice of the customer. This is customer's demand. So it includes specific activities that the foundry industry needs to improve upon, how the foundry has to change. The objective is to have robust processes and which will minimize the risk of having casting defects in automobile castings. You will see there are some booklets here, and these booklets are here which are given by different applications, and this is basically applicable to sites where the customer specific parts of production and services are processed throughout the automotive supply chain. That is what is there. You can see the different booklets here again. These are the booklets given by the customers. You can see the Ford, Toyota, and other companies. Each supplier will give a booklet to his supplier about his own requirements, but they are basically more or less similar to what CQI-27 is demanding. Some of them could be bypassed depending on the customer's needs, but generally 90%, 95% had to be added. And this all content is given below the heading in the supplier manual. If you go to the page where it says Assessment of the Supplier Quality System, CQI-27, you can see what is given in that supplier's manual. The system has different tables, and these tables are like, you can go through that one by one: ductile iron, gray iron, centrifugal liners, etc. Then aluminum piston, zinc high pressure die cast, compacted or CG iron. So these are different tables for each process. Each table is identified and certain things are told in these processes what is to be followed. I'll show you a typical table for centrifugal liners. You may not be able to see the entire table. I'll show it to you again. Well, let us see what it says. It says that it mentions on the left-hand side in the column item, the category or the process step, the requirement, then observations, comments about the actual condition, and whether it is conforming or not conforming or not applicable. So you have to mention in that tabular form about each process. I'll try to show it more clearly now. You can see here, I will read it again for you. The process table C for centrifugal liner says, if it say the process is preheat, then it says automated spinner cells must be designed such that filing on the locating surfaces of core prints is not allowed. That is a condition. Then you can put your observations, whether it is conforming, not conforming, not applicable, etc. Or in the cleaning, it says an automated reciprocator must be used to clean the inside diameter of the mold before each cycle. So all is identified one by one in this table. Another is sand casting. Under the process core box design, it says core boxes must be designed such that filing on the locating surfaces of the core pits is not allowed. Avoid blow tubes, vents, parting lines on the locating surface. Again, you have to put observations, comments, conforming, not conforming, etc. This is a big table, about 5-6 pages, and we have to follow this table if you have to conform to the CQI standard. So how to do it? I'll try to make it as simple as possible. For a foundry, if you want to comply with CQI-27, it is like it is something similar to reducing the RPNs, that is risk priority numbers. It is a numeric assessment of risk assigned to a process. Suppose we take a process and assign a number depending on the risk. Then we say the risk is very high, very low of rejection. So based on that, we give them some numbers or some steps. And this is called failure modes and effective analysis, FMEA. If the RPM values are lower, it means that the customer is less likely to receive bad parts. So we give low RPM value, less bad parts. So it is just like our any process which we give some marks or grades. Like when you give a car for servicing, they call us and say, "Were you happy with our service? Please rank it from 1 to 10." Similarly, we rank each process and rank the probability of defect happening from 1 to 10 scale. That is called RPM number. So if the RPM value is less, the number of bad parts will be less. These are simple mathematics, but I will not go into complexity just now. And the other part is PFMEA, that is process failure mode effects analysis. There is a team of your own staff which assigns each failure mode some numeric value. Just I mentioned 1 to 10 scale. A particular likelihood of occurrence. So the occurrence is high, number is high. If the occurrence is less, number may be 1 or 2. Likelihood of detection, impact on process, all this taken into consideration, and some numbers are assigned. And this is basically a structured analytical tool which is used by the organization to identify and evaluate the potential failure of any process. Some of you may be already doing it. Again, please forget the mathematics. Just let us understand the process. How this happened, the FMES came in 1940s when the US military developed the technique for each process component. You know, the defense is very particular and very specific about their needs. So they have to be very careful in their processes, specifications. So they started applying this tool. In the 1960s, NASA adapted this methodology, and the Apollo launch and subsequent NASA missions, all were successful by using this. And now it is already used in civil aviation industry to assess aircraft safety. For example, recently we had an aircraft crash. So this tool will be definitely adapted and applied to find out what has gone wrong. Those who are watching National Geographic channels, air crash, disaster, or how it is done, you understand there is a specific process how this is done. Then automotive industry started adapting it in 1970s. Ford was the first one. Then other manufacturers worldwide started following it. Then we heard about AIAG a few minutes back. This was formed in 1982. And then VDA, that is German Association, and these they joined, and this momentum got very high velocity. So the question will be, which methodology I should use? The questions are very simple. If your customer says that you should use one or other processes, yes, then you have to use that. If not specified, then what to do? And if your business is new to FEMA, then what is to be done? Then it makes sense to start with the AIAG-VDA method, which provides a much better defined step-by-step process, which I'll explain, and ultimately will lead to more effective risk reduction. And finally, those who are already using some traditional FEMAs, and if you're finding they're effective, you can continue using that. There is no problem. As long as you're following some method, it is fine. So what are the steps? I'll try to make it simple. First is review the process. Use a process flow chart for each process component. Then list each process component in the table. Then if you find that the process is too big, then try to break the process into small segments. So you can make a process sub-processes and try to make more processes. So a big process becomes a cluster of small processes. So it will be a clue if the process has to be divided into small components. Then you brainstorm the basically potential failure causes, review the existing documentation and the data, find the clues about all the ways each component can have failures, make an exhaustive list, then take a pause, wait for some time, then think again. There will always be some potential failures which you might have missed for each component, so add them. This is step number 2. Then we go to step number 3. So what are the effects of each failure on the component or the process? So impact of failure will have some effect or subsequent steps in the process. So list them. Again, I'm repeating, take a pause, think again, then maybe there will be more than one effect on each failure. Like they say, if you have a problem, just sleep over it for a day. Next day you can start afresh and find something else. So you have to think and think and think. So make it as foolproof as possible. Then you have to give rankings. As I told you earlier, you have to give severity rankings from 1 to 10. These are based on the severity of the failures. If the failure is bad, it could be 10. If it is very small, it could be 2 or 3. Then give occurrence ranking, how many times it is occurring. These are different rankings. So again, rank them from 1 to 10. It's a guide. So you'll know how many times it is happening. Then how many times, how you can detect it before it occurs. So sometimes you are not able to detect it at all. So it will be 10. If you're detecting regularly, it could be 1 or 2. So depending on detection level, you can again rank the detection level. Then finally, you have to calculate the RPN. That is a risk priority number, as I told you earlier. RPN is equal to severity ranking into occurrence ranking into detection. I give an example. If you are giving severity score is 6, occurrence score is 4, detection is 4, your RPN is 96. This all ranking is given on scale 1 to 10. For severity 1 to 10, occurrence 1 to 10, detection 1 to 10. Finally, the score will be out of 100. So RPN will be 96, for example. Or it could be more than that. So depending on RPN, we'll know whether it is high or low. And as I told you earlier, lower the RPN, the more defects you will get in your product. I hope I've been able to communicate correctly and you are able to follow the RPN number properly. Then you have to develop an action plan. Depending on RPN numbers, we must bring the RPN number down. So first of all, focus on the highest RPNs, maximum occurrences, that is maximum RPNs. and define in your team who will do what and when, have a roadmap and start working, and take action and do that regularly, implement the improvements, identify your PFME team, and calculate the resulting RPN, whether it is coming down, it is remaining stable, or why maybe surprisingly it is going up. You have to find out exactly what is happening. But anyway, try to bring it down as possible and determine the impact on the improvements. So whenever any RPN number comes down, you'll find there is improvement in your process automatically. When you reach to this step, then you have completed the FMA process and you'll be happy to come back to the CQI-27 table and you can fill up the data very properly. Coming to the other mode, that is failure mode and effects analysis. Again, it is similar but slightly different. You have to review the process. Again, use a flow chart to identify each process component. Then you have to label each component. Then what you have to do is for each component, again, list intended function or the failures or what is it is supposed to do. Then this review makes all team members familiar with the process. This is very important because this process involves the entire team. And when the team is involved, they know the entire process very thoroughly. And as I told you earlier, the top management to the bottom, they have to work together with all transparency in the process. So anything a small, a lower level worker or staff or supervisor to manager or the general manager, they have to involve this process. So all can contribute. So this is important because there are team members who do not work regularly for the process. So when they do not work regularly with the process, then what happens? You are going to miss some points. So it is necessary that all team members are involved, whosoever is working on the process. And you should also involve people who are not working in the process, so they can look at the process from a different angle and they can give some suggestions. And then this is to identify each of the main components of the process and determine function or functions of each of those components. Each component's function is identified and you can come back to the process, again go to the component, and after doing so 2 to 10 times, depending on whether you are reaching the final conclusion, you will find out that no further work may be needed because possibly you understood the process well for each component and then you are able to do something for that component. And these steps ensures that all components of the process are studied. Possibly your foundry has never gone into this exercise at all till today. But when you do that, all components from say compressors to heat treatment to machining to tooling or whatever you think of, all processes, all components in the processes will be studied by various people who are working on the process, not working on the process, and they will be able to contribute something and they will come to that. Then brainstorm potential failures. Because when you brainstorm these failure modes again, then again you have to list them, these numbers, and then you can give them numbers using the list of components, related functions generated in the step 1 as a team. Then you can give failure modes for each function. Then you come finish step number 2. Then you determine the effects for each failure mode, and again define the effects. As with the failure modes, we have done the exercise earlier, so you know what to do again here. Again, you give a ranking from 1 to 10. The severity ranking is the ranking given for the effect. And severity ranking is from 1 to 10, that is extremely low to dangerously high. The failure, how high the ranking is, means the failure rate is going to be very high. Then you give occurrence rankings, as I told you earlier. When you go occurrence rankings, again the probability occurrence is from 1 to 10. Remote occurrence is 1. Occurrence very high will be 10. So this way you can do that. Then you go detect rankings. Here again, You have done it earlier, same process is repeated here. Then again give it from 1 to 10. If detection is certain, you give one number. If you are not able to detect, you give 10. So 1 to 10 will give the ranking for the detection. Higher the non-detection, it will be 10. So naturally, high non-detection means high RPN will come. When you calculate the RPN as before, if the severity score is 6, occurrence is 4, again RPN is 96. I'm repeating the same numbers here, but number will be different. Just an example, the higher the RPN, the higher the relative risk. And again, the RPN will give excellent tool to prioritize the focused improved efforts where the improvement is needed in our processes. Then you have to develop an action plan. And action plan means reducing the RPN. Reduction in the detection ranking can be accomplished by improving the process controls in place. This is very important. So when you do that, the process can be improved. And what is considered as an acceptable RPN? The answer to that will depend on the organization. You would like to have as low RPN as possible, but you can decide what is the lowest possible in your RPN given the circumstances. And the most powerful tools are mistake proofing, statistical process control, design of experiments. If you are following that already in your company, then this will be easier for you to do that. So you can reach that stage very fast. And of course, stage 9 will be you have to take action. Unless you take action, nothing will happen. Take review meetings, brainstorming, take a pause, take meetings, and finally calculate the resulting RPN, which is best possible in your company. Possibly you reach a stage where you cannot improve more than that. Like in any process, this is the best you can do in process given the circumstances. It could be casting, it could be machining, depending on the equipment availability, depending on the manpower competence. This is the best you can do in your company. And similarly, the best RPN number available or possible in the company can be determined by this RPN number. What your customer says? The customer only says that we request both suppliers and also your suppliers carry out a self-assessment on an annual basis in accordance with CQI standards. This is what the customer simply tells you. And he says that it should be in accordance with CQI standards if any of your process is mentioned in the tables. I showed a lot of tables, A to M, from heat treatment to machining to plating and all that. So if any of those processes is being done in your company, then CQI-27 standard as a total has to be followed, and the data sheet must have been filled with a assessment at least once in a year. And it is supplier's responsibility to select the more appropriate process table among the all proposed tables. So you have to select the table which is applicable to you for each standard. So as I mentioned just now, depending on the process which you are using, heat treatment, centrifugal liners, iron casting, non-ferrous casting, aluminum casting, use that table. And that standard will be applicable to you to meet the overall CQI-27 standard. But that alone will not be enough because you'll be using aluminum casting, making aluminum casting. You'll be making heat treatment for that. You may be machining that, you may be plating that or anything. So all those tables will be compiled together and that will meet the CQI-27 standard finally. Secondly, all parts which are undergoing a special process, whether you are purchasing or treated at your facility. Suppose I am supplier, so if I am supplying to somebody, I might have bought something from outside and I'm supplying to my customer after some process at my factory. They must be identified to cascade engineering because finally I am the supplier to one company and my sub-suppliers are my suppliers. They are not suppliers to the final company. So I am responsible for the final product. So I must have a cascade engineering process to take all these standards taken care into CQI-27 standards. And these all special processes are defined in the table, so they must be taken. I'll give an example. Suppose I'm supplying castings to a company, and the castings are heat treated. I'm buying castings, and I'm only giving heat treatment and supplying to my customer. And I'm responsible for the castings as well as heat treatment and then the final supply. So I must follow both the tables for heat treatment as well as iron casting. So all what is applicable to my product and the process must be followed. And an applicable AIG CQI form, that is the table which I showed you, must be completed in all parts. You cannot keep something blank. And they must be used for everybody, and they must be filled up as directed by the customer. When the customer gives a supplier's manual, then you have to fill up everything exactly what customer wants. Please appreciate today you have got quality of two kinds. One is inbuilt quality that your company will have own specific standards or own way of working, own way of maintaining certain norms. But finally, it is a customer who tells you to do something extra, and you have to meet his standards, whether it is a universal standard or it is BIS standard or not. Whatever customer demands is a standard for you. It is an external standard, I'll say, and it could be a BIS or DIN or some standard, or it may not be, but you have to follow that standard because your customer wants that way. So you have to follow that standard. So this is what all customer demands from you. So once you have a dialogue with your customer, with your team, it is not difficult at all. Just as some of you may be following some CQI standards for heat treatment, for example, CQI-9. It is very complex, long, about 80-page standard. But once you understand and master it, it's very simple. And please remember that these standards are updated from time to time. Today, the standard CQI-27 is edition 2. Edition 1 was there, but now it is edited to make it edition 2. They take into consideration the views of all suppliers and academicians, researchers, and modify as per the needs. And they try to make it as stringent as possible, but also they do not try to make it too stringent, which may not be possible in today's scenario. So get it from a bitter pill, yes, but a sugar-coated bitter pill which will make you happy in the final process. Once you master the standard, it's very easy. So finally, I will say you should go for CQI-27. You should go for it. Hit the central hole, and I wish all of you to grow and prosper. Thank you.